Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss about 19 ITT 204 microcontroller and embedded system subject under the topic quality attributes and embedded system. So embedded system is the basics of combining hardware with software. So based on the past two units, if you watched my previous YouTube video, means you have the knowledge of how a microprocessor is working, how a microcontroller is working. Now the embedded system is the advanced versions of both the microprocessor and the microcontroller. Now let us move on to the video. So in general, first we see the quality attributes of embedded system. Quality attributes are the non-functional requirements that need to be documented properly in any system design. If the quality attributes are more concrete and measurable, it will give a positive impact on the system development process and the end product. That is, before you are going to do any embedded system oriented product, first we see what are all the important qualities of this embedded system. For example, if you want to go with any good friendship with one member, first you have to check the quality of that members. So that is why for any product we need to check the quality. The various quality attributes that needs to be addressed in any embedded system development are broadly classified into two, namely operational quality attributes and non-operational quality attributes. First we discuss on operational quality attributes. It represents the relevant quality attributes related to the embedded system when it is in the operational mode or online mode. That is, when it is in acting mode, these attributes are considered. The important quality attributes coming under this category are: first one is the response, how they react, throughput, reliability, maintainability, security, and safety. So these 6 factors are very important for considering any embedded systems. First one is the response. Response is a measure of quickness of the system. It gives you an idea about how fast your system is tracking the changes in input variables. Most of the embedded systems demand fast response, which should be almost real time. For example, an embedded system deployed in flight control application should respond in a real time manner. Any response delay in the system will create potential damages to the safety of the flight as well as the passengers. It is not necessary that all embedded systems should be real time in response. For example, the response time required for an electric toy is not at all time. That is, for different sets of applications, we need the different time period of response. So next one is the throughput. Throughput deals with the efficiency of a system. In general, it can be defined as the rate of production or operation of a defined process over a stated period of time. The rates can be expressed in terms of units of products, batches produced, or any other meaningful measurements. In the case of a card reader, throughput means how many transactions the reader can perform in a minute or in an hour or in a day. That is, for that particular period of time, how the product can be expressed in different applications. Throughput is generally measured in terms of benchmark. A benchmark is a reference point by which something can be measured. The benchmark can be set of performance criteria that a product is expected to standard product that can be used for comparing other products of the same product. Reliability. Reliability is a measure of how much you can rely upon the proper functioning of the system, or what is the percentage of susceptibility of the system to failures. Mean time between failures and mean time to repair are the terms used in defining system reliability. This mean time between failure gives the frequency of failure in hours, weeks, or months. Mean time to repair shows how long the system is allowed to be out of order following a failure. For an embedded system with critical application need, it should be of the order of minutes. Maintainability. Maintainability deals with support and maintenance to the end user or client in case of technical issues and product failures, or on the basis of a routine checkup backup. Reliability and maintainability are considered as two complementary disciplines for more reliable system means a system with less corrective maintainability required, and it can be a vice versa. So in this YouTube, I started with what is in the embedded system and what are the importance of quality attributes of embedded system. Next video, I will give the continuation of this operational attributes. Thank you for watching my video.